Jai Hind to all. Myself Alok Kumar, and today we are going to discuss the Maison gain formula in subject control system. So to start with, first of all, we will see how we can write the Maison gain formula, or what is the formula for Maison gain. So basically, in control system, when we try to find out the transfer function of a complex system, then we have to use the Maison gain formula. Okay, and according to this, we can write T will be is equal to, T represents the transfer function, T will be is equal to summation of Pk delta k divided by delta. Okay, in this formula, k represents the number of forward paths, right? Pk represents the gain of kth forward path, Then if we define this delta first, then delta is 1 minus sum of all individual loop gains right, plus sum of gain product of two non-touching loops, right, minus sum of gain product of three non-touching loops, and so on. So this is delta, and what is this delta k? Delta k is, we can say it is same as delta, it will be same as delta, but for forward path, that will be kth forward path, right? And what we have to take, we have to remove the touching loops. For kth forward path, remove the touching loop. Okay, so this is the Maison gain formula, and using this formula we can find the transfer function of the system. Okay, so we will see by an example, and we will also define some key parameters or some definitions in this. So if we take a formula, so if we take this example, in this example we can see, if we define, suppose this node is x1, this node is x2, this node is x3, x4, x5, s6. Okay, so how we can define the nodes? First definition, that is for nodes, what do you mean by node? Node is nothing but, we can say, signal or the variable of the system, signal or variable of the system. right. Next we can define the branch. What do you mean by branch? Branch is the line which is connecting or joining two nodes. Okay, so line that is connecting two nodes. Okay, now we can define a source node. So what do you mean by source node? Source node is that node which has all outgoing branches. Okay, so that type of node is called source node. Then we come to the sink node. Sink node is that node which has all incoming branches. Only. Okay. Then come to next definition, that is for forward path. So if we go from source node to sink node, okay, so it will start this path. This will start from source node and terminates at sink node. Okay, so this is called forward path. Now we come to the loop. So here you can see this is a loop. Okay, in this we can see this loop is starting from x1, then we are going from x1 to x2 and coming back to x1. So we can say loop is a closed path. It is the closed path. Okay, and we are starting from this node and ending on this node. That means it will start and terminates on the same node. Okay. Now one node, we can say there can be a self node also, okay, or self loop also. So suppose if we have this condition, then this loop will be called self loop. So self loop is also, we can also define it as it will start and terminate on the same node, but here in this loop and in this self loop there is a difference. In this normal loop there are more than one nodes, okay, but in self loop there can be only one node. Okay, so this is the difference between loop and self loop. So one definition we can give for self loop also. So self loop it is also a closed path, but it will cover only one node. Okay, so these are the basic definitions that are related to the signal flow graph technique, or we can say the Maison gain formula. Okay, so now we will see that how we can solve the problems that are using this formula. Okay, so this is the example. Okay, so we will try to solve this. So first of all, we will try to find out the forward paths in this diagram. Okay, so forward path means that we have to go from source node to sink node. Okay, from R to C. So how many paths are there, we have to find out. So first of all, first forward path we can write P1. If we follow this G2, if we go from node 1 to node 2, then node 3, then node 4, that is the forward path gain of this path will be G2, G4 and G6. Okay, so it will be G2, G4 and G6. Okay, similarly the second forward path will be, second forward path P2 will be if we go from node 1 to node 6, then node 5 and then node 4. So it should be G3, G5 and G7. G3, G5 and G7. Okay. Similarly, the third forward path will be, if we go from node 1 to node 2, then node 5 and then node 4. So the forward path gain will be G2, G1 and G7. Okay. So G2, G1 and G7, right. Similarly, we can write the next forward path P4. If we go from node 1 to node 6, then node 6 to node 3 and then node 4. So it will be G3, G8, G6. G3, G8, G6. So next forward path P5. P5 will be, if we go from node 1 if we go from node 1 to node 2 to node 5 to node 6, then to node 3 and to node 4. Okay. So this fifth forward path will be, if we go from node 1 to node 2, node 2 to node 5, then node 5 to node 6 using this feedback path, and then node 6 to node 3 and then node 4. So if we write the forward path gain for this, it will be G2, G1, minus H2. Okay, this one is minus H2, then G8 and then G6. G8 and G6. Okay, similarly, the last forward path we can write P6. P6 we can go from node 1, we can come from node 1 to node 6, then node 6 to node 3. Okay, then node 3 to node 2, then node 2 to node 5 and then node 4. Okay, so this we can write G3, G8, minus H1 and then G1 and G7. So these will be the forward paths in the given problem. Okay. Now we will try to find out the loops in this. Okay. So here, if we write the number of loops, so first loop will be this one. Okay. So we can write L1 is equal to G4 into minus H1. So minus G4 into H1. This will be the gain of this loop. Then second loop will be this. Okay. This is the first one, this is second one. So this one will be the second loop. So L2 will be G5 into minus H2. So we can write minus G5 into H2. Okay. So there should be a third loop also, L3, and it can be, if we go from node 3 to node 2, then node 2 to node 5, node 5 to node 6 and node 6 to node 3. So loop 3 will be, if we go from node 3 to node 2, that is minus H1, okay, minus H1, then G1, then minus H2, then G8. So this will be the third loop. Okay. Now we can find the value of delta. Okay. So in next slide we will see. So delta will be 1 minus sum of all individual loops. So here we have 3 loops, L1, L2 and L3. So we can write, this will be minus G4 into H1, this will be minus G5 into H2, and this will be, this minus minus will get plus, so it will be G1, G8, H1, H2. G1, G8, H1, H2, right? So if I write this, so here it should be L1 plus L2 plus L3, okay, then plus sum of two non-touching loops, sum of gain product of two non-touching loops. So we have to find that how many loops are non-touching here. Okay, so here we can see this L1 and L2, this is L1 and this one is L2, these two loops are non-touching in this case. So here we can write L1 into L2. So this will be the value of delta. Now we can put the value of this L1, L2 and L3. So delta will be 1 minus, L1 is minus G4H1 minus G4H1, L2 is minus G5H2, G5H2 and L3 is G1, G8, H1, H2, G1, G8, H1, H2, okay. And now come to this L1 into L2, so product of these two, okay. So these two values are negative, so the product will be positive, so it will be G4, G5, G4, G5, H1 and H2, H1 and H2. So this will be the value of delta. Further we can multiply this minus sign in the bracket, so it will be 1 plus G4 H1 plus G5 H2 minus G1 G8 H1 H2 and plus G4 G5 H1 H2, right? So this will be the value of delta. Now here we have 6 forward paths, and with these forward paths we can find the value of delta 1, delta 2, delta 3 and up to delta 6 we have to find out. So first one we will try to find out delta 1. So delta 1 will be 1 minus sum of gain product of individual loops which are non-touching to this forward path. So this forward path is G2, G4 and G6, G2, G4 and G6, and in this forward path these two loops are touching, okay, two loops are touching and only L2 is non-touching. So here we can write delta 1 will be 1 minus L2, and here we know the value of L2, so we can write 1 minus of G5 H2, so it will be 1 plus G5 H2. So this will be the value of delta 1. Now we can find delta 2 for forward path P2. So delta 2 will be, now forward path P2 is G3, G5, G7, G3, G5, G7. So with this forward path, this L1 loop is non-touching. So here we can write 1 minus L1, okay. So it will be 1 minus L1 is G4 H1 minus G4 H1. So it will be 1 plus G4 H1, okay. Now we can find delta 3. Delta 3 will be related to the forward path P3. Forward path P3 is G2, G1, G7. So it is G2, G1, G7. Now with this path all loops are touching, loop L1, L2, L3, all loops are touching this forward path, okay. So here this delta 3 will be 1 minus 0, that will be is equal to 1. Then we can find delta 4. Delta 4 related to forward path P4, it is G3, G8, G6, G3, G8, G6. Again all loops are touching this forward path. So this delta 4 will be 1 minus 0, so it will be 1. Now we can find delta 5. Delta 5 will be related to this forward path P5. So it is G2, G1, G2, G1, H2, G8 and G6. Again all the loops are touching this forward path, and similarly we can say that when we come to forward path P6, in this also all loops are touching this forward path, okay. So the value of delta 5 will be 1 and also the value of delta 6 will be 1. Now according to the Maison gain formula, the transfer function will be this T is equal to P1 delta 1 plus P2 delta 2 plus P3 delta 3 plus P4 delta 4 plus P5 delta 5 plus P6 delta 6 divided by delta. So all the values we have calculated. Now we can simply put here, we can put the value of P1 and delta 1, okay, then we can write the value of P2 and delta 2, then we can write P3 delta 3, and similarly P6 delta 6 up to P6 delta 6, and delta also we have calculated here. This is the value for the delta. So if you put this, we will be able to find the transfer function. Okay, so this is the way how we can solve the problems using the Maison gain formula. Now come to the next problem. Okay, now coming to this problem, problem 3. In this problem you can see a block diagram is given to us. So first we will convert this block diagram into signal flow graph, okay, and then we will solve it. We will find the transfer function using the Maison gain formula. So to convert it into the signal flow graph, if we nominate these summing points and takeoff points here, we can write this is A, B, this one is C, D, E and F. Okay, so now this summing point can be replaced by a node. Okay, this is node A. Then coming to second summing point, that is represented by node B. So here the gain factor will be 1 because there is nothing between these two summing points. Okay, then we have gain factor G1 and summing point C. Okay, so coming to summing point C, it will be represented by a node, and here we have gain factor, that is G1. Okay, after this I think that should be D, it should be E, okay, and then DE, and it will be F, and it will be G here. Okay, so from C to D, because it's a takeoff point, so it will be represented by a node. So this is nothing but D, and the gain will be 1 in between C and D. Then after this we have gain factor G2. So G2 will be the gain of this branch, and we have a takeoff point that will be represented by a node E. Okay, then we have a gain factor G3. We have gain factor G3 and a summing point that will be represented by a node, that is F. Okay, after this we have a takeoff point that will further represented by a node, and the gain between these E, F and G, gain between this F and G will be 1, and from here we are taking our output, that is CS, and here we are applying our input, that is RS. Okay, so now we can see node this node D to node E or node F, one signal is going, that is G4, okay, in forward path or in forward direction. So node D to node F. So here we can show this is G4, this is in forward direction. Then one feedback is coming from this node E to node B, node E to node B. So in this direction we can show, and the value of this, because here this feedback is negative, so we can show here it is minus H1. Okay, again we can see one feedback signal is coming from this node G to node D. So node D and G we can connect, and signal is coming in this direction. Again it is having negative feedback, so we can write minus H2 here, right? Then one feedback signal is coming and coming to node A, from node G to node A. So we can connect node A and node G, and the feedback signal is having the gain of -1. Okay, so this will be the signal flow graph for this problem. Now we will try to find out the forward path in this case, okay, in this problem. So first forward path will be, if we go in straight line, that is node A to node B to node C to node D, E, F and G. So we will cover all these nodes, and we can go from RS to CS, or source node to sink node. So the gain for this forward path will be G1, G2, G3. Okay, so forward path gain will be G1, G2 and G3. Can we find out any other forward path here? Yes, there is one more forward path, that is if we go from node A to node B, C, D, and from node D to node F we can go, and then to node G. So the gain for this forward path will be G1 G4, right? So G1 into G4. Now we can find the loops. So first loop will be L1, and L1 we can write, we can see here G1, if we go from node B to node E and then come back to node B, okay. So G1 G2 into minus H1, G1 G2 into minus H1. Then second loop will be, if we go from node D to node G and then coming back to node D, so G2 G3 minus H2, G2 G3 minus H2, okay. Now the third loop will be, if we go from node A to node G and coming back to node A, so this will be L3. So L3 will be G1 G2 G3 into minus 1, G1 G2 G3 into minus 1, okay. Any other loop we can find out? Is there any other loop? Yes, if we go from node D to node F to node G and then coming back to node D, so the gain for this loop will be G4 into 1 into minus H2. So this will be the loop number 4, and the gain will be G4 into minus H2. This will be the fourth loop. Any other loop we can find? We can go from node A to node D to node F to node G and coming back to node A. This will be loop number 5. So the gain will be G1 G4 into minus 1. So G1 G4 into minus 1. Okay, so I think these are the 5 loops that are possible in this signal flow graph. Okay, now we can find the value of delta. So delta will be 1 minus L1 plus L2 plus L3 plus L4 plus L5, summation of all individual loop gains plus sum of two non-touching. In this problem, can we find out the combination of two non-touching loop gains? Okay, so is it possible? Because L1, this is L1, that is G1 G2 into minus H1, this loop is touching to L2 also, L3 also, L4 also, and L5 also. Because two non-touching means there should be no common, there cannot be no common node, no common branch, and no common, we can say, no common path. Okay, so only that node will be called as non-touching loops. So there is no non-touching loops exist in this case. So here this value will be 0. So delta will be 1 minus, we can write the values of these loops L1 L2. L1 is G1 G2 minus H1, so we can write minus G1 G2 H1 plus L2 is G2 G3 H2. So here we can write minus G2 G3 H2, G2 G3 H2, then L3 is minus G1 G2 G3 minus G1 G2 G3, then L4 is minus G4 H2 minus G4 H2, and L5 is minus G1 G4 minus G1 G4. So if we multiply this minus sign, or we can take minus common, so it will be 1 plus G1 G2 H1 plus G2 G3 H2 plus G1 G2 G3 plus G4 H2 plus G1 G4. This will be the value of delta. Now we have two forward paths here. So with these two forward paths we can find the value of delta 1 and delta 2. So delta 1 will be 1 minus sum of all individual loop gains which are not touching this forward path. So all loops are touching this forward path. Okay, so there is not a single loop which is not touching this forward path. So 1 minus 0, so delta 1 will be 1. Similarly we can find delta 2. Again all loops are touching forward path P2 also. So 1 minus 0, it will be 1. So now we can find the transfer function. So transfer function T will be is equal to P1 into delta 1 plus P2 into delta 2 divided by delta. So now we can put the values. So P1 is G1, G2, G3, G1, G2, G3, P2 is G1, G4, it is G1, G4 divided by the value of delta that is written here. So 1 plus G1, G2, H1 plus G2, G3, H2 plus G1, G2, G3 plus G4, H2 plus G1, G4. So this will be the transfer function of the given system. Okay. Now coming to this problem, in this problem we can see the problem is given in the form of signals. First we will try to draw the signal flow graph using this data, and then we can find the transfer function. So we will see how we can draw the signal flow graph using these equations. Okay. So here first of all we will see we will identify how many nodes can be there. So nodes we have already seen nodes are the number of variables or signals available in the system. So here we can see there are 5 variables, that is x1, x2, x3 and x4 and x5. So we can draw these. So here we have x1, then we have x2, x3, x4 and x5. So this is x1, x2, x3, x4 and x5. Okay. So at node x2, x2 is equal to a12 into x1. So one signal is coming from node x1 and the gain of this is a12. Okay. One signal at x2 is coming from x3. Okay. So this is node x3, one signal is coming, so that should be in this direction and the gain is a32. Then from node 4 one signal is coming, okay, in this direction and the gain is a42. Then from node 5 one signal is coming and the gain is a52. Okay, this is for first equation, right? Now coming to the second one, second is x3 is equal to a23 into x2. Okay, so x3 is equal to, so one signal is coming in this direction and the gain is a23. This is for second equation. Now coming to third equation, x4 is equal to a34 into x3. So one signal is going in this direction and gain is a34. One signal is coming from x1. Okay, so this is x1 node and one signal is coming and going to x4 node and the gain is a44. Right. Now coming to the last equation is x5 is equal to a35. So one signal is coming from node 3. Okay, so at 5 one node is signal coming from node 3, that is a35. Okay, and one signal is coming from node 4, that is a45. So this is the way how we can draw the signal flow graph using the equations, given equations. Okay. And now we can find the transfer function as we have discussed in the previous examples. Okay. So thank you.